Hello, welcome back. I've added a new thing to these videos. So just in the corner, I've just added what learning intention the video matches to. So this is for learning intention 5. So I noticed it was a bit hard to match the video to the learning intention. So I've added that here. So what we're going to do now is sketch graphs, except restrict the domain. So this means sketch them, but only for an interval of x values or a certain amount of x values. I'll give you two examples. I'm going to give you one of a log graph. So this all builds on everything you've done so far. This builds on all the sketching you've done so far. So the question might look like sketch. Let's see what I've got here. I've got 2 natural log negative x plus 1. However, it'll have something like 4x is less than negative half. And it'll almost always, on an exam, whether it's in the same question or it's a multi-part question, it'll pretty much always ask for the range. It'll say state the range. So just a quick side note to remind you, if you have some graph, so let's have, I'm going to make up some curve. There's my curve, and it has some endpoints. So the domain is all of the x values here, that's the domain. And the range is all of the y values. So just in case we need to remember, that's the domain, that's the range. To do this, you follow the steps we've done before. So we're going to state dilation, reflection, translation. We're going to sketch mini graphs, except we just have to be conscious of this final bit here, and we'll come to that. So let's do dilation, reflection, translation. So we have a dilation by a factor of 2, and that's going to be from the x-axis. We have a reflection, so that's negative x, so all the x value is going to be flipped, so that's in the y-axis. So reflection in the y-axis, and then we have a translation of 1 unit up. There we are. Let's do some mini graphs. Well, a log graph, let's see, it's a reflection of e to the x. So a log graph is going to start here, and then next it's by a factor of 2 from the x-axis. So we're going to be getting further away from the x-axis. So it might look something like that. A reflection in the y-axis, so the y-axis becomes our mirror. So let's reflect in the y-axis. And then a translation of 1 unit up. Okay, well that's there. It's going to be 1 unit up, so it might look something like that. Okay, that's good. We already have a rough idea of what our graph's going to look like. Now, the thing with domain restrictions is that it's better to work out the 4 points and then start sketching your graphs. So the 4 important points are turning points, asymptotes, endpoints, and intercepts. Well, we know we have an intercept there. Let's find that. That's going to be an x-intercept. Let's make y equals 0. Ooh, I need to label this properly. Y equals. Okay, 0 equals 2 natural log negative x plus 1. Let's minus 1 from both sides and divide both sides by 2. So we get negative a half equals natural log negative x. Here's where we need to remember our log laws. So we can rewrite this, and I've done this in a previous video. We can rewrite this as e to the negative half equals negative x. Now, if you're not sure why that happens, don't worry, because Learning Intention 7 covers this as well. So for now, you can accept it, but you will need to know it at some stage. Also do it in a different video. And we can keep going here. That was meant to be an arrow. So we get x equals negative e to the negative half. Now, I'm going to be good, and I'm going to write this with a positive index. So I'm going to make this positive, and the way I'm going to do that is by putting it down the bottom. So I get x equals negative 1 on e to the half. Now that's correct, but just to be extra fancy, I'm going to replace the power of a half by a square root, because we know they mean the same thing. That's super fancy. That looks very nice right there for your x-intercept. So let's write that down. So there's our x-intercept. We've found the x-intercept there. We know the asymptote. We know the asymptote because it's only been translated 1 unit up. So we know the asymptote remains the same at x equals 0. So we can give ourselves a little note to remind us of that. So that's pretty much it, except we need to consider this now. And considering this, well, we're going to have to think about what this number actually means here. So let me just do a quick check over my working. I've got negative 1 here, divide both sides by 2, e to the power of a half equals negative x. Yep. So let's come up with what this number is roughly. You probably get a graphics for something like this. I doubt they would give you something this tricky, but e is about 3. You need to know that the square root of 3 is about 1.7. So 1 on 1.7, well, if that's approximately negative 1 on 1.7, you know that this x-intercept happens like here. You know that. And you know that the negative half must be in there. It must be there because you have negative 1 on 1.7. If this was like about a half, well, half of 1.7 is about 0.85. So this is slightly more negative than half. So you can see it's just over this side. If that's a bit tricky, that's okay. I doubt you would get something that close to approximate without a calculator. It's likely you would get a calculator for something like this. But let's keep going with it. So we know that we're going to have an endpoint just there, and we need to find the y value of our endpoint. So let's find the y value by subbing in x. So let's see. Oh, sorry, that's the x-intercept. So we'll find the y value by subbing in this value of x here. So let's find the y value. So let's see, we want the endpoint. So we're going to go y equals 2 natural log negative, and we're subbing in negative a half into there. Negative a half plus 1 equals 2 natural log half plus 1. That's fine. You can leave it like that. That's exact form. That's it. That's exact form. I can tell you what this will roughly equal. This quantity is about negative 0.693, and if you double that, it's more negative than negative 1. So this whole quantity will work out to be negative, but once again, that's pretty tricky. You're likely to get a graphics for that, but that quantity will turn out to be negative, and that's what we expect. So we've got the endpoint coordinate, so we know that our endpoint is at, let's see, negative a half, 2 natural log a half plus 1. Look at that. That's pretty ugly. It's pretty hideous. So we've got all our information. Now I just want to emphasize over here, whoops, I didn't mean to zoom in. Bear with me. Yeah, I want to emphasize over here that this asymptote, because it stops there, like it just stops. You don't actually have to put in the asymptote because it's not approaching it. So because it goes like this and then hits the endpoint, stops, we wouldn't put in the asymptote. So that's a really important point. You don't need the asymptote there. And that will, if you don't put it in, you'll be showing that you understand that. So that's one way you can really show your examiners that you know what you're doing. Alright, well we've got all the important information. Let's sketch the graph. So I'm going to clear this. Alright, so you can see why big axes would be really important here as well, because you saw those exact values we have to write in, they're huge. So we're going to make lots of room to do that. Nice big axes as usual, and I notice lots of people drawing much bigger axes when they're sketching their graphs, which is great to see. Alright, well we know our endpoint, let's just put it here. Well, it's going to be roughly there. We're not going to have an asymptote, so we don't put that in. I'm going to do my best to sketch this. Alright, not quite. I think it looks more like, no. There we are. Okay. And that's going to go off to infinity. So let's see, we need to mark our intercept, which we decided earlier was -1 on root E0. So you can see why I think the big axes are really important for fitting in these points. And we're going to put our endpoint in there, which is -1/2 to natural log a half plus 1. There you are, that's your graph. Now there's one thing I haven't done, and that's state the range. So we can already state the domain because it was given in the question. So the domain is, I forgot something. It's less than -1/2. I've got to make sure that's an open circle because I'm not including -1/2. That's embarrassing because its x is less than -1/2. It's not including. So our domain we already know there. Well, the range, I'm just going to doodle over this graph. The range is going to be from down here all the way to infinity. So it's going to be from here all the way to infinity. So how are we going to write that? We can say the range is y is greater than 2 natural log of a half plus 1. There we are, there's our domain and range. Now, that looks ugly, but it's not actually too bad because you're just kind of subbing in a number and simplifying as much as possible. That's exact form. So exact form looks ugly, but it makes our lives easier. So there's one graph. I'm going to show you one more because that was quite a tricky example. Let's do one more graph with a restricted domain. Alright, this one, examiners love putting on non-calculator exams. They love doing this. They'll say sketch y equals the absolute value of x squared minus 4. They'll put some graph in absolute value bars because they know it trips up half of the state, but you're not going to get tripped up by it because I'm going to show you how to do it. For -9 to 9. So this time I'm including -9 and 9. It's the same story here. Ignore the absolute value bars for now and just treat it like it was y equals x squared minus 4. Well, let's see, no dilation. no reflection. So we have a translation of 4 units down. So our graph originally looks like that, and it's translated 4 units down. It's going to look something like that. Alright, now you can consider the absolute value bars. All this does here, it just makes everything positive. So all the y values that are negative down here, all these y values, all you have to do is make them positive. So you just draw the graph again and make all those y values positive. That's it. That's all it's saying to do, and it trips up a lot of people. So watch out for that. Now that you've seen it, you know it's not that scary, but it can scare people in exams because it's not like a familiar routine question. So they slip in some absolute value bars and think they're going to trick you, but you're not going to get tricked by that. Alright, what can we see? We've got some x-intercepts. Beautiful. We've got a y-intercept. We have no asymptotes, and we can work out our endpoints. So let's work out our x-intercepts. So we're going to make y equals 0. So we've got 0 equals the absolute value of x squared minus 4. Alright, well in this case we know from looking at our mini graphs that the x-intercepts are going to be the same as this one here. So let's just ignore the absolute value bars. 0 equals x squared minus 4. 4 equals x squared. X equals, watch out, what's the square root of 4? It's plus minus 2. Because, yeah, 2 times 2 is 4, but minus 2 times minus 2 is 4. So we've got two answers for this, plus minus 2, which makes sense because you've got like the minus 2 value here and the plus 2 value here. What about this y-intercept? Y-intercept, x equals 0, y equals the absolute value of 0 squared minus 4. 0 squared is 0. The absolute value of minus 4 is 4. We've got that down. Cool, let's write down our x-intercepts. So we have negative 2, 0, and 2, 0. Over here we have 0, 4. Is that it? No, we need our endpoints. So that would be it if we didn't have this domain restriction. But let's find the endpoints. First, let's guesstimate. So, you know, 2 is about there for the x value. So we want to go up to 9. So we're going to have one endpoint there. And we're going to go to negative 9. So we're going to have one endpoint there. Let's do our endpoints. So we've got y equals 9 squared minus 4. So what I've done there is I've taken that 9 and subbed it in right there. Right there. Alright, 9 squared is 81 minus 4 is 77. So we have the absolute value of 77, which is 77. Next, let's sub in negative 9. Well, I hope you can guess what answer this is going to give, given the previous answer. 9 squared is 81, so negative 9 squared is 81. So we get 77 again. Let's put in our endpoint. So we've got when x is negative 9, y is 77, and when x is 9, y is 77. Now you've figured out all your points for your graph. And you can see why the mini graph is useful because it tells you what points to look for. You're not trying to look for y-intercepts or x-intercepts that don't exist. You're always guaranteed, yep, I know exactly what points to do for, and you all know how to find those points. So that's why the mini graphs can be very useful. Alright, so in a moment, I'm going to clear this screen and we're going to sketch this graph on nice big axes. You ready? Bam. Where's my ruler? There's my ruler. 1, 2. Get that a bit straighter there. Okay, cross that one out. Let's see here. So we knew from our mini graph it's going to look something like this. It's going to kind of bounce like that. I reckon that's pretty good. Let's put in all our points. So we worked out that that's -2, 0. We worked out that that's 2, 0. This endpoint here we worked out was 9, 77. This one's -9, 77. Notice how I'm shading them in. I got it right this time because the domain is this interval here. So because it has that include sign there, I know to shade it in. If it was like this, then I'd know to keep the circle empty. Finally, let's put in our y-intercept. So our y-intercept ends up being 0, 4. Because we're good students, we're going to state our range. Our range is, well, it's all the y values. So the y values go from 0 all the way up to 77. So our range is from 0 all the way up to 77. And that's your answer. Adding domain restrictions is as simple as finding the endpoints. It's everything you've been doing except add in these endpoints here. And if you have been, thanks for watching this video.